Okay, once again, good day, my dear students. In this learning activity sheet, we are going to discuss systems of nonlinear equations. So, a little background on this topic. When we think of system of equations, we simply recall a set of many equations. These equations could be a combination of at least one equation that is not linear, and this one is called a nonlinear system. Similar in solving system of linear equations, technique being used here in nonlinear equations also involves um, substitution, elimination, and the graphical method. So to illustrate this one, let's try to adopt the first example. We have here x squared plus y equals 5, and we have x minus y equals 15. Based on our knowledge in the conic section, we can say that the first one here is a parabola, and here the second equation is very obvious that that one is a linear. So it's a combination of a parabola and a line. Now, using this method, by just simply inspecting the given, it is more simple to work on the second equation because we can rewrite the second equation as y equals x minus 15. Then after that, we are going to substitute this one to the second equation. So we have here now x squared plus your y, which is x minus 15. You change that one to x minus 15 equals 5. Then distribute the sign to eliminate the grouping symbol. We have here now positive, positive, okay, positive, positive, negative. We have negative. So we have here now x squared plus x minus 20 equals 0. Now, by applying our knowledge in factoring, we can use here the trial and error method. So we come up with the factor x plus 5 and x minus 4. We try to check it. Our goal is to get the middle term, which is 1x. So we have here 5 times x, that is 5x, negative 4 times x, that is, we have negative 4x. Get their sum, then we have positive x. So tama yung factor natin. So we have here now the roots as negative 5 and 4. That is done by equating x plus 5 to 0 and x minus 4 to 0. So we have here now negative 5 and 4. Now, if our x is negative 5, we can substitute that one to the second equation, because this one is the simple one to use. We have here now, we come up with the value y equals negative 20. So just to show that one, we have here x minus y equals 15. X is negative 5. Then we have minus y equals 15. Okay. Or simply, by transposing negative y to the other side of the equation, lipat natin dito. Similarly, here, 15 will be transposed here. So, magiging negative yung 15 natin. So, we come up now with y equals negative 20. Okay? So, that is how we get negative 20. Yon, yung negative 20 dito. Of course, when our x is equal to 4, using this equation again, we come up with y equals negative 11. Okay? Now, as a result here, you would have now the 2 points. We have negative 5 and 20. We also have 4 and negative 11. Now, before in our linear systems, when we solve linear system and graph them, we say that The intersection is simply the solution. So graph is already provided here. We have here now a parabola and a line. Their intersection, as we have mentioned a while back, the intersection is simply the solution. So we have here now point 4 and negative 11 and point negative 5 and negative 20. So these are now the solution set of these systems of nonlinear equation. Hope you understand it. So moving on, we are now going to use the other method, the elimination method in this example. So we have here x squared plus y squared equals 34 and negative 2x squared plus y squared equals 7. The first equation is obviously a circle because both are positive. The second equation is a parabola, or sorry, it's a hyperbola rather, because the one is negative. Okay? First step is we are going to eliminate y squared, and that is done by multiplying negative 1 to the first equation. That leads now to negative x squared minus y squared equals negative 34. Then after that, the product now will be added to the second equation. Here we have the second equation. We add it. Then we have here now negative x squared minus 2x squared, that is negative 3x squared. Negative y squared is and positive y squared is being cancelled. We have negative 34 and 7, that is negative 27. Then simplifying that further, we are to multiply negative 1/3 here. Okay, 1/3. So negative 1/3 times negative 3x squared, that is simply x squared equals, we have here negative 27 times negative 1/3, that gives us now positive 9. Then after that, we are going to extract the root. So we get the square root of 9. Okay, square root of 9. There we go. We have now positive and negative 3. Next is, how about if we are going to eliminate x squared? Eliminating x squared, we simply multiply 2 to the first equation. That gives us now 2x squared plus 2y squared equals 68. Then after that, this one is to be added to the second equation. So we have the product of the equation, which we have here, we multiply 2, we have 2x squared plus 2y squared equals 68. Then the second equation is negative 2x squared plus y squared equals 7. So we miss the sign here, negative. Let's indicate it. Okay, adding this one will lead now to 3y squared equals 75. Dividing this one into 3, we have here now y squared is equal to 25. Y squared is equal to 25. Then we get the square root. We have here now positive and negative 3. Or we can immediately substitute the value that we have here, x equals positive negative 3, in the equation that we wish to use. So here we use the first equation, positive and negative 3 is being substituted here. We come up with y squared equals 25. So the ordered pair now that we have is, we have negative 3 and negative 5. We also have here 3 and negative 5. negative 3 and 5, and the last is we have 3 and 5. Graphically, if we try to look at the graph, we have the intersections, we have 4 points, wherein the solution that we have here is being revealed. We have here negative 3 and 5, okay, negative 3 and 5. We have 3 and 5, there we have 3 and 5, negative 3 and negative 5, we have there, negative 3 and, we have 3 and negative 5, we have here. So which happens that that one is the intersections. And as I've mentioning a while back, that the intersection is simply the solution of the non-linear system. Okay? Hope you understand that one. We move to the third example. So we are going to use the graphical method here, and the approach here is presented very simple, but of course graphical method uh, is not recommended. It's more better to use substitution or the elimination method. But for the sake of discussion, let's try to have this one. So we provided values for x and we solved for y. So when your x is 4, then your y is 2. When your x is 3, then we have 1.84, and so on and so forth. Until such time, you would notice that there are values here which are the same. We use equation 1 here. Then here we use equation 2. And you would notice now that there are similar values here, making us now conclude that this one is the intersection of the graph. So these are the intersection of the graph. So graph is already provided here. You would notice that the one that we are mentioning here, 4, 2, is an intersection in the graph. 0 and 4 is also an intersection in the graph. Okay? So here we have another example. This time it's an application problem, wherein here we are going to get the sum of two integers and their square. So we have here the sum of two integers is 24. Writing that one into a mathematical symbol, we have x plus y equals 24 if we let x be the first integer and y be the second integer. Another is the sum of their squares is 36. So writing that one in a mathematical symbol, we square x, we square y, get their sum. So we have here now x squared plus y squared equals 36. So using the substitution method, we have here now, we work on the first equation because this is the simple one to use. We can write it and let y be the independent variable. So we have y is equal to negative x plus 24. So that is done by transposing x to the other side of the equation, and that one now leads to the negative sign of x. Here we have x squared, which is the second equation, plus we substitute y here. So we have negative x plus 24 quantity square is equal to 306. Expanding that one, we square the first term, that will now becomes positive. So we have x squared. For the middle term, we have negative 4 or negative x times 24, that is negative 24. Add it to itself, we have negative 48x, that is for the middle term, and then for the last term, we just square 24, so we have 576. Okay, simplifying this further, we come up with 2x squared minus 48x plus 270. And of course, we can further simplify this one if we are going to multiply 1/2 to the equation. So that leads now to x squared minus 24x plus 135. Again, trial and error is being used here. We have the factors as x minus 15 and x minus 9. To check it, we have the middle term should be negative 24. You have to get the product of, we have negative 15 times x, that is negative 15x, negative 9, and x, that is negative 9x. Get their sum. We have here now the middle term. So tama yung ating factor dito. So the roots now is simply when this one is equated to 0, x minus 15 and x minus 9, we have here now x equals 15 and x equals 9. So if our x is 15, then we can solve for our y, and that is 9. If our x is equal to 9, then we can solve for y. Our y is equal to 15. So we can say now that the integers are 9 and 15. So hope you understand that part. Just to show that one, we have, if x is equal to 15, we can simply use this one. You have your y is equal to 15 negative negative 15 plus 24. So that is simply our value 9. So similar, you have y equals 9. So you just apply that process to have y equals 15. Okay? So moving on, do take note that the learning competency that we have here is we are going to illustrate systems of nonlinear equations, and also we are going to determine solutions of system of nonlinear equations by using the different techniques: substitution, elimination, and the graphical method. Okay? So we also to solve situational problems involving systems of nonlinear equations. So let's try to apply all the things that we have learned in our discussion by having these exercises. We can pick number 3, okay? Here we are going to state if the points given is a solution of the system of equation. So let's try to adopt the number 3 exercises here. We have, okay, provided y value is already provided here. So you just simply substitute that y value here in the first equation. That gives us now x plus 10, which is the value of y, equals, we have x squared plus 2x minus 2. Then after that, we transpose x to the other side of the equation. Similarly, 10 here is being transposed, so that we come up now with this final equation: x squared, negative na yung x, positive yon, so that is positive x. You have 10 transpose negative, and we also have your negative 2, so that is negative 12 equals 0. By trial and error, possible factor for 12 is 4 and 3, so we can get the middle term. So factors, we have x plus positive, so we have the higher value 4, and we have here x minus 3 equals 0. So we equated to 0. That gives us now x equals negative 4 and 3. And you would notice we have here 3, which is also a point here. Part, part of the point for the x value, we have 3. So from this, we can conclude that this one is a solution. Okay? So yes, it's a solution. Okay? So that is for that problem. So we move to the next. The remaining problem will be left for you to solve. Next is we are going to solve the given system and sketch the graph in one Cartesian plane. And then we try to show the point of intersection. So we can adopt example number 1 here. X squared plus y squared equals 25. Obviously, that one is a circle. Negative x plus y equals 1 is a line. So we work on the second equation. We can rewrite that one as y equals 1. Lipat natin sa kabila. So we have plus x. So 1 plus x or x plus 1 or x plus 1. Then after that, this one is to be substituted here sa y. Okay? So, substitute natin siya. We have here now x squared plus, you have x plus 1, x plus 1 square. So we already changed the y value here to x plus 1 equals 25. Simplifying this further, or expanding rather, the second term, we have here now x squared plus x squared plus the middle term, 1x and 1x, that is 2x, and then square the last, plus 1 equals 25. Okay? Then we have here now x squared and x squared, that is 2x squared. We have plus 2x. We indicate 2x here. Then you have positive 1 and positive 25 on the other side. When we transpose 25 here, that becomes negative. Added to positive 1, that is negative 24 equals 0. Okay? Simplifying this further by dividing this one into 2. Then we have here now x squared plus x minus 12 equals 0. Or factors now, trial and error again. We have x. Factors for 12 is 4 and 3. We have x plus 4 and x minus 3 equals 0. Equating this one to 0, that gives us now x is equal to negative 4 and positive 3. Okay? So, if our x is negative 3, if x is equal to negative 4, then we can just simply use this equation, y equals x plus 1, y equals x plus 1. If your y is 4, then if your x is 4, we have negative 4 plus 1. That is now equal to what? Negative 3. So the first pair now is you have negative 4 and negative 3. In like manner, when your x is equal to 3, so you have your y is equal to, you have 3 plus 1. So that gives us now 4. And that gives us now uh, the point 3 and 4. Okay, let's try to check the answer here if we are correct. Answer is being provided here. Okay, so we have here negative 4 and negative 3. Then we have 3 and 4. So let's try to use the figure here. Um, let's try to zoom in this part. So we have here now, you would see here that the intersection is 3 and 4. We have here 3 and 4 graphically. The intersection is the solution. We have negative 4 and negative 3. So that is how we do it. So hope you understand that part. Let's go back to the next problem. So let's try to use what example. So in the application, let's try to use number 2 problem. So we have here, to greet the 2020 senior high graduates, a tarpaulin is to be set up along the national highway, wherein the area of the tarpaulin is 35 over 4 square meter and its perimeter is 27 over 2 meters. What should be the dimension of the tarpaulin? What do you think? Okay, so let's try to solve that one by using a clear area here in this part. So we have the perimeter. The perimeter is given by the formula P is equal to twice the length twice the width. But the perimeter is already given, that is perimeter is 27 over 2. Okay, so we have 27 over 2 is equal to twice of L plus twice of W. So we have the first equation here. We have the first equation. Second is we have the area. Area is equal to length times the width. But the area is already given, that is 35 over 4. 35 over 4 square meter is equal to length, the length times the width. So we can consider this one as our second equation. So how are we going to solve that one? How are we going to find the dimensions of the tarpaulin? Using the substitution method, I think it's more better to work with here in the second equation. We can simplify this one by multiplying it to 4. If we multiply it to 4, then that gives us now 35 is equal to 4 times the length and the width. Okay? Or simply, we can have what? We can have 4W or 4L is equal to 35 over W. Then after that, we are going to substitute that one in the second equation. Okay? We are going to substitute that one in the second equation. So we have, or it could be our option is we work on the first equation. So for example, we work on the second equation so that we can compare if which is more better to use. If we multiply 2 here, this one is simplified to 27 is equal to 4W plus, or sorry, this should be, okay, parehas lang naman, 4W plus 4L. Okay? Then after that, we solve for L or either W. So that gives us now L, say L, we're going to solve for L. L is equal to, or 4L is equal to, we have 27. We have 27 minus 4W. If we are going to multiply it to 1/4, then that gives us now L is equal to 27 minus 4W over 4. Okay? Then if we are going to substitute this one to this equation to the second equation, 35 over 4 equals LW, then we have here now we have 35 over 4. We have 35 over 4 being the area over 4 is equal to, we have length times width, but our length is 27 minus 4W over 4 times W. So you would notice that we substituted the value of L. Here we have now a one variable involved, which is W. So working on this, we multiply 4 to further simplify it. We multiply it to 4. Then that gives us now 35 is equal to, we have 4 here is being cancelled. So we have 27 minus 4, or yes, 4W times W. Okay? So simplifying that further, we have here now 35 is equal to, we multiply W, so we have 27 W is equal or minus 4W square. Or we can arrange that one as we have 4W square, let's make it positive, minus 27W positive, negative, then we have 35, we transpose negative 4W here, we have positive, we transpose 35, 27W here, that is positive, stable, the sign of 35 is stable, okay, we have 35 equals 0. Then by trial and error, we can have here now 4W minus 7. Then we have here W minus 35 equals 0. Okay? Or sorry, this should be uh, 5, not 35. So 5 equating now to 0. That gives us now W is equal to 7/4, and we have 5. So we have 7/4 and 5. So from this alone, we can conclude that now that the dimension of the tarpaulin is 7/4 meter by 5 meter. Okay? So that's all for that application problem. Hope you understand it. Thank you very much.